that black holes exist. It's an actual movie of a black hole devouring a star in the constellation of Aquila. Black holes are messy eaters. The red spots you see are gas that's being spit out of the hole into space. Eventually, over the next million years, this star will be eaten alive and disappear.
A black hole is pretty much the endpoint of everything. It's the endpoint of a star, it's the endpoint of matter, it's the endpoint of energy, it's the endpoint of gravity. I mean, that's really it. That's the top of the scale.
Although they have the power to destroy like nothing else in the universe, black holes also help build galaxies, a vital part of the great cosmic machine. Some astronomers think they could even be gateways to parallel universes.
We are now entering the golden age of research in black hole physics. They could be the key to understanding the birth of the universe, its formation, and then its death.
Black holes really represent, in one sense, the frontier of modern astronomy. They're changing our ideas about how galaxies form and, indeed, how the universe works.
Their power comes from one of the primary forces in nature, gravity.
I teach astronomy. We teach our students that the fundamental principle of gravity is gravity sucks.
Gravity keeps our feet on the ground and our planet orbiting around the sun. But in a black hole, the force of gravity is off the charts. So strong, it sucks in anything nearby. It can even bend the light from distant stars. And if that light gets too close, the black hole swallows it. Think of it like this. Imagine a black hole as a waterfall. Gravity is the river flowing toward the falls, and a beam of light, the kayak. Upriver from the waterfall, the current is weak. The kayaker can paddle against it and get away. But closer to the waterfall, the current is stronger, and the kayaker struggles to escape. The edge of the waterfall is like the edge of a black hole. No matter how strong the kayaker is, he's going down. It's the same in space.
The way black holes are really devastating is because when you get close to them, the gravity gets super strong.
So strong that they eat light. That's why black holes are black.
A black hole is like a roach motel. Everything checks in, nothing checks out.
Anything that gets too close is doomed. Planets, stars, even whole solar systems. And don't think this is some faraway phenomenon. Black holes are on the loose right here in our own cosmic neighborhood.
We now know there are wandering nomads throughout the Milky Way galaxy, vagabonds throughout the galaxy, where black holes can come up right behind you and perhaps gobble you up, and they won't even burp. If one ever comes close, watch out.
If a black hole found its way into our solar system, it would rip us apart.
Any kind of black hole that could pass through the solar system would be pulling on all the planets harder than the sun does. And so it's just going to totally disrupt the gravitational balance of the solar system.
The black hole would literally tear planets from their orbits and smash them into each other.
It's just an epic disaster. It's a bull in a china shop. If it got close enough to, say, Jupiter, it could actually pull the moons of Jupiter away from the planet itself. It would just be flinging planets left and right everywhere as it whipped through the solar system, leaving disaster in its wake.
If a black hole approached Earth, all that gravity would rip asteroids from their orbits and hurl them toward our planet. The Earth's surface would become an inferno. It would be the beginning of the end. First, it would swallow up the atmosphere, then the planet itself. Destroying an entire solar system is nothing to a black hole. But it's more than just a big, empty, sucking piece of space. It's incredibly heavy. To get an idea of just how heavy and dense a black hole is, imagine the Earth. Now, start to crush it. And keep crushing until it's packed so tight, even the atoms themselves collapse. When the Earth crushes down to just 2 inches across, that's the density of a black hole. It would be the size of a golf ball, yet weigh the same as the Earth, with the same amount of gravity. What can make something that small, that dense, and that powerful?
We don't have external forces, large pistons in the universe to create black holes. So the only way the real black holes in the universe form is if gravity can do the job itself.
There is only one place in the universe that generates that much gravity, and it's inside the largest stars. When massive stars, 10 times heavier than our sun, die, gravity crushes them, creating a huge explosion, a supernova. But some stars are even bigger than that. These supermassive stars weigh 100 times more than our sun and have 100 times more gravity. When one of these stars dies, it sets off the biggest explosion in the universe, a hypernova. This is the birth of a black hole. Our universe is full of stars. At the end of their lives, some die quietly. Others go out in spectacular explosions. And some give birth to black holes.
If you have a star, a supermassive star that's 100 times the mass of the sun, at the end of its life, the core runs out of fuel. There's nothing left to hold it up, and the core collapses down into a black hole.
When that happens, the enormous gravity generated at the heart of supermassive stars runs wild. This is the dying star, VY Canis Majoris. It's more than 1 billion miles across. Like all stars, it's a giant nuclear fusion reactor, pumping energy outward. At the same time, the star's extreme gravity crushes inward. For a few million years, fusion and gravity are locked in standoff. But when the star runs out of fuel, fusion stops, and the stalemate ends. Gravity wins. In a millisecond, the core shrinks to a fraction of its original size, and a baby black hole is born. Immediately, it starts to cannibalize what's left of the star.
As matter swirls into the black hole, it gets incredibly hot, and there are magnetic forces and frictional forces, and it's just a witch's brew, a nightmare what's going on right above the surface of the black hole.
The new black hole in the middle keeps feeding on the body of the star around it. It eats the gas so fast, it chokes and coughs, blasting out huge beams of energy.
They basically eat their way out from the star. This happens in milliseconds. It happens before the rest of the star even knows the core is gone. And so basically the star is dead before it hits the ground.
Finally, the star explodes. In 1 second, it blasts out 100 times more energy than our sun will produce over its entire life. What's left is a new black hole and 2 jets of energy hurtling through the universe at the speed of light. These jets are called gamma-ray bursts.
They're incredibly energetic events. In terms of raw energy and power, gamma-ray bursts are second only to the Big Bang itself.
Most of them last only a few seconds, and they fry anything in their way.
They're so intense that if there was a gamma-ray burster in the region of our galaxy near our solar system, it could literally vaporize the entire planet.
Fortunately, most gamma-ray bursts occur outside our galaxy. but they tell us something important about black holes and how our universe works.
What we were seeing every time a gamma ray burst went off was basically the birth cry of a black hole.
By counting gamma ray bursts, astronomers can figure out how many black holes are being created. In 2004, NASA launched the SWIFT probe to scan the universe for gamma ray bursts.
5, 4, 3, 2, 1. We have ignition, and we have liftoff of NASA's SWIFT spacecraft on a mission to study and understand gamma ray bursts throughout the universe.
This is the most powerful gamma ray burst SWIFT has detected so far. The flash of light announces the birth of a new black hole on the other side of the universe. SWIFT can only look at a fraction of what's out there. Still, it detects at least one gamma ray burst every day. That discovery rocked astronomy to its foundations.
We once thought that black holes like unicorns could never be found. We now believe that there are perhaps billions of black holes in the night sky.
When we look around our galaxy and other galaxies, it's clear that the universe is full of powerful black holes.
Finding black holes is one thing. Figuring out how they work, that's a whole different ballgame. The only way to find out is to visit one. You'd have to take a spacecraft across the vastness of space just to get close to it. Then you'd have to go inside the black hole. There, you'd find a place where reality breaks down and time stands still. There are billions of black holes in the universe. We can detect them with telescopes and satellites, but we don't actually know what they're like up close. It's a long way off, but scientists are already speculating about a mission to a black hole. A one-way trip to the most dangerous place in the universe.
Originally, physicists were horrified at the idea of black holes. They wanted to banish them because the laws of physics as we know them seem to break down at the instant of a black hole. Time stops. Gravity becomes infinite. This is a nightmare.
Obviously, we can't send humans anywhere near a black hole. But a robot? Well, sure. A robotic probe could transmit data back just before it goes over the edge. That edge of a black hole is called the event horizon. It's the edge of time and space, at least in the universe we know.
We call the event horizon quite simply because it separates space into two regions. It's not a physical surface. You might not even notice it if you were falling through it. But ultimately, once you're inside of it, you're doomed.
As you approach the event horizon, gravity gets stronger, and very strange things start to happen.
As you fall into a black hole, feet first, your feet are closer to the black hole, and so the gravity they feel is stronger. Your head is not quite as close, and so the gravity it feels is less. And basically what happens is you get stretched out. Your feet are being pulled much harder than your head, and you're like a piece of taffy being pulled between two strong people. As you get thinner and thinner and thinner, as you get closer and closer and closer, you're undergoing a process we call spaghettification, because you're basically turned into a long, thin tube of pasta.
Gravity would stretch our robotic probe to the limit, then rip it apart. But imagine if the probe was strong enough to survive and keep going. As it gets close to the event horizon, everything goes crazy. Gravity is so extreme, it stops time.
We think of time as being endless. However, in a black hole, in some sense, time stops.
This sounds like it's nuts, but that's the way it works. It's in the math. It's actually woven into the fabric of the universe itself.
If you were to watch from a distance, the robot probe would seem to slow down as it gets closer to the black hole. Then, it would appear to stop completely.
The whole process might just take a brief moment, but from the outside, you appear to freeze and fall ever more slowly. You actually can never observe an object fall all the way through the event horizon. It literally freezes at the surface because its clock is going infinitely slowly compared to yours.
In reality, the probe hasn't stopped at all. It keeps going, and crosses the event horizon. If the probe points its cameras backwards towards the entrance of the black hole, it'll see light being sucked in. If it points the camera forward, at first it sees only black. But as it moves toward the heart of the black hole, it encounters the most bizarre place in the universe. The black hole's immense gravity pulls everything down to an unimaginably small point at its center. Scientists call it the singularity.
We really just don't know what happens at the center of a black hole. The densities are so great that the laws of physics break down as we know them.
A singularity is a point of infinite gravity where space and time become meaningless. Now, that is ridiculous. A singularity is basically a word for saying, I don't know. It's a word for saying, I'm clueless.
Even now, scientists can't really answer the question, what is a black hole?
It's upsetting a little bit to think that there are objects out there that are breaking the laws of physics. There must be bigger laws that are being used by these black holes, that are being obeyed by these black holes that we just don't understand yet.
Okay, so the one thing we do understand is that black holes are born from dying stars. And most are small, around 20 miles across. But now, scientists have discovered that some black holes are much bigger. They're called supermassive black holes. They're the same size as our entire solar system. And one of these monsters lies at the heart of our own galaxy. Our solar system lies in the Milky Way galaxy. It's made up of billions of stars, including our sun, all revolving around a mysterious region right at the center.
Children ask the question, if the moon goes around the Earth goes around the sun, then what does the sun go around?
It's a good question, and astronomers ask the same thing. Maybe there was something going on at the heart of the Milky Way, perhaps a black hole at the very center. But because we can't actually see a black hole, the best they could do was look for telltale signs. Using infrared telescopes, they looked at the middle of the galaxy and discovered a densely packed swarm of millions of stars. But they couldn't see what was at the center. One team has spent 15 years looking for clues. High above the clouds on Mauna Kea in Hawaii, the giant Keck telescope has the power to see right through to the center of the Milky Way.
The region which we have to study to prove that there's a black hole is incredibly small. It is absolutely the case of looking for a needle in a haystack, except we know exactly where the needle is.
Andrea Ghez has spent countless nights scanning the center of the galaxy for signs of a black hole.
To be able to do this experiment, one has to be able to see the stars that are very close to the center of the galaxy and to position them incredibly accurately. And this would be equivalent to me in Los Angeles looking at you in New York and seeing you be able to move your finger like this.
As the Keck kicks into action, a laser beam detects tiny disturbances in the atmosphere that would distort the image. Motors then adjust the huge 30-foot mirror to compensate. The image is clear enough to track the stars at the heart of our galaxy. Ghez has taken thousands of images over the last 15 years. And what they reveal is amazing. The stars at the center of the galaxy are moving at millions of miles an hour.
The center of the galaxy is a very extreme environment. The speeds with which stars move is much higher than anywhere else in our galaxy, and that is absolutely the signpost of the black hole.
They look like tiny planets racing around an invisible sun. But they're not planets, they're stars. It takes a lot of gravity to swing huge stars around in such fast, tight orbits. There's only one thing in the universe with that much pull: a supermassive black hole.
Watching these things shows the presence of a 4 million times the mass of our sun black hole located right at the heart of our galaxy.
It is a huge discovery. Everything in our galaxy, including our own solar system, orbits around a supermassive black hole. But the Milky Way isn't the only galaxy with a black hole in the middle. There are supermassive black holes at the heart of most galaxies in the universe. The Andromeda Galaxy is our closest neighbor. It circles around a supermassive black hole weighing 140 million times more than our sun. Other galaxies, like this one, M87, have black holes weighing as much as 20 billion suns. How do black holes get so big, and what are they doing at the center of galaxies? For answers, we have to go back nearly 14 billion years to the beginning of the universe. Back then, the universe was filled with clouds of gas from the Big Bang. In some places, the gas was thick enough for millions of stars to form. Most of these new stars were supermassive. They burned hot and fast, and then exploded, creating lots of black holes.
The early universe was a wild and crazy place where huge regions of mass were collapsing catastrophically, producing black holes, and in fact, the early universe might have been full of emerging black holes everywhere.
Gravity pulled many of them together. All over the early universe, they merged, creating larger and larger black holes. Over hundreds of millions of years, each black hole grew, producing stronger gravity and pulling in more and more gas. New stars were born from the gas, forming primitive galaxies. But the black hole kept on sucking in gas until it could take no more, igniting the most powerful flamethrower in the universe. A young galaxy is a vast cluster of stars, stars that formed from clouds of gas. At the center of the new galaxy is a young, supermassive black hole, feeding on the gas, getting bigger and bigger.
If you can imagine, when a galaxy is very young and still forming, there's a supermassive black hole forming at the core, and the gas is still falling into it and still forming the galaxy. Well, near that central black hole, things are getting very hot. That material's heating up.
Gas is speeding into the black hole, but it overloads, and there's no room for all that excess hot gas. It has nowhere to go but out. It's blasted into space in huge jets of energy. Each jet is 20 times wider than our solar system and shoots clear through the galaxy. The supermassive black hole has ignited a quasar.
Quasars are literally the brightest objects in the universe. They're so intense they can outshine an entire galaxy.
This is a real photograph of a real quasar in the galaxy M87, 50 million light years away. Quasars blast away huge quantities of gas from the surrounding galaxy, the equivalent of 10 Earths every minute.
When you heat up a gas, it tends to expand and it blows outward. And it's sort of like a wind, but on a huge scale. And you get a black hole wind, gas blowing out from the black hole.
Black holes suck gas in. Quasars blow it out. But eventually, there's no gas left to make stars, and the galaxy stops growing.
So we think that the eventual size that a galaxy can achieve depends on the black hole in its center. The two are tied together.
With no gas left to feed on, the quasar jets shrink and die. What's left is a supermassive black hole at the center of the galaxy with a whole lot of young stars, just like our Milky Way, back when it was young.
Early on in the history of the Milky Way, when it was a young galaxy, We were probably a quasar. Probably every big galaxy was a quasar when it was young. But right now, we're old enough that the galaxy has quieted down.
Now, astronomers are looking for quasars, the secret to finding more black holes and figuring out how they work. The Chandra Observatory is a space telescope that can detect the powerful X-rays quasars send out. It's found thousands. These remarkable images show quasars of all shapes and sizes, firing out into space. Each one is a signpost for a young galaxy with a new black hole at its center. These quasars will eventually calm down as their galaxy matures and takes its final shape.
I guess the universe is a lot like people. Active when they're young, a little bit quieter and more relaxed when they get older.
We now know that supermassive black holes and the quasars they create control galaxies.
Black holes are central to understanding how galaxies form. They're key to understanding how they evolve with time. So in fact, rather than being obscura, they're fundamental to our understanding of our galaxies and our universe.
The only way to find out more about black holes is to get a good look at one. And since an up-close visit is, well, not a good idea, astronomers are trying to devise a way to take a picture of the supermassive black hole at the heart of our own galaxy. To get it, they'll need a telescope as large as Earth itself. There's a supermassive black hole at the center of the Milky Way. It's hidden by a dense cluster of stars circling the heart of the galaxy. But soon, we hope we'll be able to see it.
Seeing is believing. It would be spectacular if we can go right up there, nose to nose, with the event horizon of the black hole at the center of the Milky Way galaxy. And that's the Holy Grail.
A supermassive black hole lies hidden at the center of most galaxies. We only know they're there because the stars around them are drawn in at millions of miles per hour. But there might still be a way to take a picture of the very edge of the black hole, the event horizon. Shep Doeleman and his team are trying to capture an image that shows its outline.
We're essentially looking for the shadow or the silhouette of the black hole within this cloud of gas that's swirling around it. This technique that we're exploiting is the best hope I think we have to actually image a region of the universe which has hitherto been completely invisible to us.
Optical telescopes can't see the black hole directly. But the glowing, superheated gas surrounding the black hole sends out radio waves that can be used to make an image. Huge radio telescopes pick up these signals from space.
The antenna will move in azimuth and elevation.
This one, at the MIT Observatory near Boston, is more than 100 feet wide. It's big enough to detect very faint radio emissions from the black hole in our own galaxy, 25,000 light years away. But it's not nearly big enough to capture an image.
We need to take multiple copies of these telescopes, place them around the world to create a virtual telescope as large as the Earth itself.
Doeleman's team will link up radio telescopes around the globe, from Hawaii to Chile to Africa. When the whole network is connected, they'll have a virtual dish over 10,000 miles across, with 500 times the power of a single telescope. They think it'll be powerful enough to take a picture of the event horizon of the supermassive black hole at the center of the Milky Way. They're already picking up signals from the dark heart of our galaxy.
When we saw the first detection, it was a moment where I just looked at the computer screen and said to myself, my God, we've done it. We've actually seen something that's so small that it has to be coming from right around the event horizon.
The signals are still too weak to give a complete picture, but Doeleman expects the images to improve as more telescopes come online over the next few years. Eventually, the outline of the black hole itself should emerge. But even a picture can't compare to witnessing it for yourself. In the distant future, we may have the technology to actually enter and pass through a black hole, and maybe even survive the journey. Then we might finally answer the question, what lies at the heart of a black hole? Some scientists believe we could use black holes as a kind of portal with the potential for travel across the universe.
This is still very speculative, but the mathematics seem to indicate that as you fall through a black hole, that you don't simply die, you fall right through a wormhole, which is a gateway, a shortcut through space and time. Perhaps we could simply rocket across the universe through a subway system that we call a black hole.
If black holes are shortcuts through space and time, it could turn one of the coolest ideas from science fiction into reality.
Time travel is possible, but not very practical. You see, the energy source, the material that you need to keep the throat of a wormhole open, is something so exotic that we cannot produce it in the laboratory. But if you could, it might be possible to exploit the power of black holes to visit yesterday. Perhaps our descendants in the future have already mastered this technology. So one day, if somebody knocks on your door and claims to be your great-great-great-great-great-great-granddaughter, don't slam the door.
Black holes might even be gateways to other universes. On the other side of a black hole, there could even be a Big Bang.
As a black hole collapses and matter falls into it, perhaps the matter is blown out the other side in a white hole. Doesn't that sound like the Big Bang?
If a Big Bang is just the flip side of a black hole, this could be how our own universe was born.
If you look at the equations for a black hole and put in the parameters of the universe, the mass of the universe, the size of the universe, bingo, you find that our universe actually solves the equations for a black hole. In other words, we could be inside an event horizon. Perhaps we are actually living inside a black hole.
Every black hole might be the origin of an entirely separate universe. If that's true, there could be billions of universes out there. Each one full of stars, planets, life. Whatever we figure out later, we know now that black holes are everywhere. They're bigger in size and more critical to the evolution of the universe than we ever imagined.
Literally, our understanding of the universe that's important around us, the universe that's visible to telescopes, has been profoundly affected by our realization that black holes are everywhere.
Once upon a time, people thought that black hole physics was too fantastic to be true. And now they are center stage. We now know they dominate the evolution of the universe itself.
When I was a kid, black holes basically played a part in science fiction. It was always something to avoid. Your spaceship, you try to get around them before you get drawn in. But what we've learned since then is that black holes play a huge role and a huge number of roles in the universe. It's not an exaggeration to say that if black holes did not exist, we wouldn't be here. We literally owe our existence to black holes.
The story's not over yet. There's still much more to be discovered about the mysterious objects called black holes, masters of the universe.